All right, so for the next, 25 or so minutes, I want to walk you through some of the ways that being in public cloud can really come back and burn you. In a lot of cases, when your company has moved to AWS, Azure, Google, it happens organically. It happens through developers saying, hey, we just opened this AWS account to go run our marketing website, and corporate IT, InfoSec aren't involved. And next thing you know, hey, we've got public buckets on the internet. We've got a whole slew of terrors and risk in our environment. Bad computer. Who am I? I've been doing IT for about 25, getting close to 28 years now. Discovered the cloud around 2014 and had been moved into an InfoSec role about 4 years ago. Mostly I work at media companies. Not finance, not healthcare, not government. So where chaos tends to be more, chaos just tends to be more prevalent. So code spaces. We're not talking about the GitHub product, but we're talking about code spaces from roughly, what would we say, 2014. They had some admin keys that somehow got leaked. Not sure how. Could have been phishing. Could have been, laptop left on a train. They got a ransom. They said, we're not paying this ransom. And that was a mistake, because everything, got deleted. Everything got deleted. Their customer data was deleted. Their backups were deleted. Everything was deleted. And all they could basically say was, sorry, everybody, I hope you had backups of your source code on your local systems. We're out of business. Tons more examples. S3 buckets have been a problem since 2016, 2017. National Reconnaissance Office left a bunch of classified images open in S3 buckets. Dow Jones had a bunch of credit cards stolen that were left in an S3 bucket. Not sure why. Verizon had a third party leave a bunch of their customer records out there. But it's more than that. You've got Open Kubernetes. Tesla got hit by that. Their Kubernetes was left exposed. Somebody got credentials. They were able to push crypto mining containers into the Tesla environment. And then Exactus, they had the first example of a public Elasticsearch cluster. AWS will just let you spin one of these things up. And AWS, up until recently at least, would let you make those public. So the cloud is different. I think everybody kind of knows that, but I try to describe it as defending your network. And if we look at castles and moats and firewalls and everything, you're defending your network, and you still need to defend your network at that two-dimensional space, but you can have that third dimension, that cloud plane that you have to defend. And so you need to not just be looking out on the horizons for armies coming to attack you. You need to be looking up. You need to be looking at the clouds to figure out whether or not your network is going to be attacked. Case in point, from the cloud, I can go and remove the firewalls that you implement through this one command. Now, there's going to be a whole bunch of AWS commands. All of those are posted on my website, so you don't need to screenshot. Just take the last screenshot of the last slide, and that'll have a link to all of this. And so, but there's even more than just the network plane and then the cloud plane. There's many perimeters of cloud. And part of that has to do with the cloud providers giving you now managed services. Cloud providers are all about, hey, how do we move the undifferentiated heavy lifting off of customers, so you're not running an Elasticsearch cluster. That's not what your business is about. Your business is about analyzing data and providing value to your customers. Elasticsearch is only there as a means to an end. And Amazon and Azure and Google are really trying to help you get rid of that undifferentiated heavy lifting to get rid of the undifferentiated heavy lifting so you can move forward in doing what you want to do. So what you end up with are, you have identities. How you are authenticating to your cloud service provider. You have resources. Those resources can have permissions directly attached to them. And then you have what we traditionally know of as our network boundary. And so all three of those end up being the things that you're looking at and the things that you're having to defend. Can't do a cloud security talk without at least bringing up one example of shared responsibility model. Everything that I'm going to talk about here is really on your side of shared responsibility. Lots of stuff out there, especially within the last week or so around, or last month or so, I guess, around cloud provider vulnerabilities. Azure, Google have had a couple of those. There's even a remote code execution that came out in some Amazon AWS-related software that is the client for their desktop as a service thing. But all of this is really attacks that can be run against your environment that you're responsible for making sure don't happen. Another concept, lateral versus vertical movement. Because as you look out across your castle, you can certainly go over land to attack, another castle. You can move from host to host, from network to network. But you can also move from a compromised host to the cloud. And you can exfiltrate cloud credentials. You can use those cloud credentials to maybe move to another Amazon account. And once you have permissions in that Amazon account, you can move back down and take over another host. And so there's this ability to laterally move both at the network plane and at the cloud plane, and then going up and going back down. So before we jump into specific attack commands, what do you need to get started in this? How hard is it really to find a foothold into an environment? So if we're thinking, a very high-level MITRE framework, initial access is pretty easy. And in a lot of cases, initial access and discovery are one and the same. Because if you have an S3 bucket on the internet, that could be your objective, is to find and exfiltrate data. There may not be any need to exploit or anything else. It might just be there for the taking. So discovery can be part of that initial access once you find the resources that you're looking for. As I said, resources can have their own policies. So that allows them to be open to anyone, any IP address. It allows them to be open to any Amazon customer. And those are very distinct distinctions that you need to be aware of, is that maybe I can go and pull your data out without ever authenticating, but maybe I just need to put in my credit card, become an Amazon AWS customer, and now I can go and pull some data out. DevOps means that credentials to cloud environments are all over the place. And so, go look for what's sitting in a GitHub repo. Go look for what's sitting in the CI/CD server. And then, privilege. We'll talk about that. But, if you've got what you think are harmless permissions, they can be very powerful. For example, the all-seeing AWS read-only access. This policy is provided by AWS, and it is intended for, hey, I need to go in and look at something. A lot of times folks are like, okay, well, this is a reasonable thing to give all of our developers. It's safe. They can't change production, which means that, you know, that's cool, right? Yeah, except that this gives you the ability to list all of the IAM users in the environment, which is great if I wanted to launch a phishing attack. I can enumerate all of the privileges that all of those users have, including my own, to see if there's any privilege escalation that I might be able to execute. It can enumerate all the resources. It can exfiltrate and download data out of S3. There's AWS read-only access, which is the most powerful of these. But there's also EC2 read-only access, which you may also think is, oh, well, you know, it can't access S3. But it can tell you, or it can tell an attacker who has access to these permissions, what are all my on-prem VPN endpoints? What IP addresses are my VPNs? And, you know, what are some of the shared credentials that are there that those VPNs need? So even EC2 and S3 read-only access are very privileged and should be, you know, should be used sparingly. So, depending on the attacker's objectives, you know, they might have been able to get what they wanted just with read-only access. But if they really want to mess around with your environment, they might need to privilege escalate. And there's a whole slew of research around AWS IAM privilege escalation that I don't have time to really walk through in 15 minutes or in 20 minutes. So I'm not going to dive too deep into these. I would recommend looking at some of Spencer Geetson, you know, rest his soul, his work from Rhino Security. And then the other thing is look at cross-account trusts. Where in your environment are you trusting one AWS account to another? Because that tells you how to go and, you know, execute lateral movement attacks in the cloud plane. All right, so low-hanging fruit is AWS S3 buckets, right? What is Amazon S3? It's their storage service. It's been around since 2006. Because it predates IAM, it had its own original authentication platform. Objects are immutable. It's a public service, which means it is not really defended by your network by default. There's no firewall you wrap around S3 to protect it. As I said, there's two ways to misconfigure it because it predates IAM, and it's a global namespace. So I own the S3 bucket for B-Sides Augusta. By the way, if you need it, you know, let me know. So, all right. Easiest attack is if you find a public bucket, you can run this command, no sign request, and that will list you all of the contents in the bucket. You can also do the exact same thing with curl. If it is not an anonymously accessible bucket, but is accessible to any AWS account, then you can use your own AWS account using, you know, -- profile. And again, you can pull down any S3 object itself just with a simple curl command. The first one is anonymous. The second one here is anonymous and works well with Tor. Third one, you know, this one you want to be careful of because, you know, that's tied to your credit card. If you start exfiltrating data through your own AWS account, you know, somebody's going to issue a subpoena and Amazon is eventually going to tell you stuff. There can also be publicly writable buckets. So this happened to the LA Times. They were tricked into, you know, or they left their bucket publicly writable. Somebody uploaded some Mage cart. And LA Times, you know, served that up for about 3 weeks. They were the first, but they weren't the last. So what does that look like? How simple is it to execute a publicly writable bucket exploit? Yeah, it's running the exact same command. If the bucket is publicly writable, you can drop anything in there just with a simple AWS or a simple curl command. And then to verify that your object is there, again, use that curl command. If you're looking at a bucket and you see a bunch of POC.txt files, that's somebody saying, hey, I noticed your bucket's public and here's my proof of it, you might want to go fix it. And if you see those POC files, that means they haven't probably fixed it because they haven't cleaned up the evidence that somebody had proof of concept of the exploit. AWS account IDs we're going to talk about in a couple of slides ahead. But one way to figure out who owns a particular bucket is you can just kind of iterate through looking at error messages. All AWS account IDs are 12 digits long. It's been a while since I've done high school math, but I think that's 12 factorial, which is not that big of a number. And it's reasonably quick to brute force what account owns a bucket simply by creating a pattern or a policy and then just iterating down through the 12 digits until you find the correct error message. And then the We Are Clouder folks have a whole tool around give it a bucket and they will tell you the account ID. Another fun area of exploit with S3 is subdomain takeovers. So typically what happens is, hey, we're going to decommission something. Well, what's the expensive piece? The expensive piece is S3. Okay, well, let's go delete S3. Okay, we've shut down the system. We're saving money, except you didn't delete the pointer to that bucket. Remember how I said S3 is a global namespace? Well, now I can go and register that S3 bucket. So this command here will go through, if you have AWS read-only access, it'll go through all the hosted zones, and it will look for all of the records, and it will look for anything that's pointing to S3. At which point, I can go and create the bucket. And now I'm serving content as you. Hopefully, I'm serving non-malicious content. So, tons of things in the cloud can be public. More and more things are becoming public every day because Amazon and Azure and Google, the major cloud providers, they're releasing new things all the time. And so the horrifying thing for me trying to defend my environment is, what the heck did Amazon just release last week? Because I've spent the last week at a big hole in the ground in Arizona. What did Amazon do in the last week? And what do I need to be telling my development teams about? So, container registries. I can make my containers public. I can leave boot volumes. I can let anyone invoke my own lambdas. Topics, the pub/sub infrastructure, the queues. Heck, I've even seen IAM roles that are publicly invocable, allowing folks to basically make a public bucket without making a public bucket. So what does it look like if we wanted to do a container registry exploit? All you pretty much need to do is, as any account, but you do have to do this, you can't do this anonymously, get a login password and then log into somebody else's ECR. If you get a login successful, you can list the images and you can download the containers. So that's one. If you got a little bit more permission, you can, write this little JSON policy and upload it with this command, and boom, now you've just made somebody's ECR public. So now you can go and pull things out. Really easy to do. If you just have read-only access and you're looking to see what policies might be there, are only some accounts trusted? You can run that. That'll give you all of the other accounts that this environment trusts, and so now you have targets for lateral movement in the cloud plane. Public Elasticsearch clusters, an AWS managed Elasticsearch cluster. Now they're calling it OpenSearch, I think. It looks like that. Customer gets to define something. Amazon will put something random on the end, and then it'll just be es.amazon.com. If you just curl that endpoint, it'll come back with, hey, for search. That's what Elasticsearch does. You find one of those in the Amazon AWS IP namespace, you've hit potentially a jackpot. Go look at the aliases, and that'll give you the indexes. And from that, then you can go and look at the content of the index itself. See if there's anything interesting in there, or if somebody else has beat you to it, and all there is a ancient ransomware node. So as I said, AWS has made it impossible now to make these public. I've tried to break things and do it the wrong way and haven't been able to. So I think we're safe here. But we're not safe here because, hey, you can actually have public disk images. So, hey, this has got all of our backup database on it. Anything that's cached to disk, your developer could make it public. So if you have a target and you're trying to see, okay, hey, are there any hard drives I can go after? Well, you can describe snapshots, and those are the real-time things. Or you can describe images, and these are typically built as for auto-scaling with completely ready to go, everything code deployed, configured, database connection strings could be in there, whatever. So both of these would allow you to just enumerate all of the disk images available within an environment. And then, of course, there's secrets. Tons of places to find secrets. The great one is UserData. So here's a command. It goes through all of the EC2 instances that are in a particular region, iterates through those, and then this command here, AWS EC2 describe instance attribute, says, give me the boot configuration data that is passed in by the user. And this is typically where you'll find a bunch of runtime stuff. Database connection strings are common. IP addresses of other resources. I've seen Kubernetes, secrets in there. Yep, yeah. Anything that's kind of like because you'll bake one of these and you'll run it in your dev environment, and you'll pass in for that, dev environment credentials, and then you'll run the same image, you'll promote it to production, and then that'll have the production environment stuff in it. So UserData is a great thing. It comes back originally base 64 encoded. So yeah, just pipe that through base 64 decode, and hey, you've got a shell script that this machine is expected to execute on start. So if we go back to what read-only access can give you, it can give you access to all of the secrets. So here we're going to list all of the secrets that AWS Secrets Manager stores, iterate through those, and get them. Boom, 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 4 commands, and you've pulled all of the secrets out of an AWS account simply by having read-only access. And then Lambda Code, another great way to, maybe there's no secrets in the Lambda Code, but you're going to find requirements.txt, you're going to find a bunch of other things that may hint to vulnerabilities, whatever. Again, fully available to you with read-only access, but you pull a list of the functions, you run the get function and you ask for the code.location, and the URL that's returned by that is anonymously accessible. So you can go and curl that down and you've got the function's zip file. Lambda environment variables are how many times runtime config is injected into the environment. Before Secrets Manager and Parameter Store, which are 2 AWS services, came along, really the only way to say, hey, this thing is prod versus this thing is dev is through environment variables. And the one thing I've realized about AWS is developers and really security folks architect for the AWS you have, not the AWS you want. And typically you don't end up re-architecting. So if you get into an account and you have access at the read-only level, you can list all of the functions, and you can pull out all of the environment variables for those. And so this will dump you a nice little JSON file that'll say DB connection string and whatever that is, or the endpoint or the API token or whatever that Lambda function is supposed to talk to. All of the dynamic configuration runtime stuff tends to be in Lambda environment variables, which are really easy to pull out. CloudFormation is Amazon's managed infrastructure as a code service. So with this command, you can describe the stacks and pull out all of the parameters. So if there was a secret that was being passed into some infrastructure or machine that was being created, here's how you pull the secrets out. If the machine itself was creating secrets, then it would output those. And so this allows you to pull out all of the outputs. There are many better ways to do this now, but there weren't 3 years ago. There weren't 2 years ago even. So your teams aren't constantly refactoring their code to take upon the latest services. So in a lot of cases, if you were to look, you would probably find things like access keys or database passwords coming in through parameters and outputs. GitHub Actions, and really GitHub in general, I think GitHub in general is like the next frontier of cloud security because so many folks are moving to GitHub for GitOps and GitHub Actions for deploying code that there's just a whole slew of places that people haven't yet poked hard enough at on it. But very simply, any secrets that are in GitHub Actions on a repo or at the organizational level can be pulled out with this, one little command. And while GitHub tries to hide secrets in the GitHub console, it's not going to hide it if you netcat it out to your own IP address. And then last but not least, your keys are stored in plain text in AWS credentials. AWS metadata abuse, we can talk a little bit about that one. That's how Capital One got hit. And that one was overly permissive role. They got in, they pulled the metadata out. They didn't detect the data exfiltration, and next thing you know, the Senate is yelling at them. A lot of these are available in a tool called Pacu, which I think has been kind of described as Metasploit for AWS. But the whole point of this really is to hit on what can happen in your environment to make sure that you know to go ahead and protect it. And if there's one thing that I would recommend is get yourself some form of cloud security posture monitoring, whether it's Scout Suite or Prisma Cloud, Divi Cloud, CloudSploit, there's a ton of them out there. They're going to tell you if your Elasticsearch clusters are open to the world. They're going to tell you if your EKS is exposed. And with that, since I am pretty much out of time, I will take any questions. All right, I talked so fast, nobody has a question. Who is horrified? I didn't horrify folks yet? Yeah, they're already horrified of me, yes.
I got a question.
Yeah.
You mentioned GitHub is kind of being the next frontier. Do you also maybe classify like Docker Hub as being another frontier for people managing their cloud environment?
I think Docker Hub is really a subset of supply chain. How do you know that the Docker container that you're pulling down, or for that matter, the Amazon AMI that you're pulling down comes from a known trusted source? And again, if you have permissions to write to somebody's Docker Hub, then yes, you can overwrite their containers. I would say yes, but I would put it less in the cloud security field and more in the how do we fix the supply chain and the supply chain trust problems. Does AWS offer any good defaults? Well, as I said, they no longer allow you to make Elasticsearch clusters public. So they've gotten good on that. If you create them through the AWS console, you have to explicitly say, I know what I'm doing, I want to shoot myself in the foot, please let me. If you create it through the command line or through infrastructure as code, the please don't, please let me shoot myself in the foot isn't there. Yeah. So yes, if you're doing things artisanally in the console, they have gotten better about it. But like, if I launch a machine, it's still going to put SSH or RDP open to the world for me. A lot of the logging monitoring stuff still isn't turned on by default. And a lot of the logging monitoring stuff is kind of free. So it kind of should be on by default. Well, it's kind of free. It's negligible in expense, which is probably why they don't do it. Cool. All right, so I'm supposed to give away practical packet analysis. So I will ask, there is a way to do packet analysis in AWS. And it's an EC2 construct. Does anybody know the name of that? I've got a lot of novice AWS users in here. So how to use Wireshark to solve, how would you get Wireshark data out of an EC2 instance without being on the instance itself? Okay. Yeah, that would work. So there's a way to do it at the cloud plane, which is called VPC flow VPC traffic mirroring. Who said that? You said PS remote. I didn't hear filter, sorry. Yeah, VPC traffic mirroring is basically a command that can be run with AWS credentials, and it will basically take all of the output of one network interface and send it to another network interface. Cool. All right, well, thank you, everybody.